Hello everyone. Today in this video we are going to discover about most important topic in JEE Mains and Advanced and most marking topic in JEE Mains and Advanced, limit. Okay. For understanding the concept of limit, we should have some basic knowledge about the some different type of function. Look like as greatest integer function, sigma function. At first, what is limit? What is limit? Limit is an investigated tool. Limit is a investigative tool which help us to make inference for point where function takes indeterminate form. What is indeterminate form? These things we discuss after some time. But what is the limit? Limit is an investigative tool which help us to make interface for the point for the where the function take the intermediate form. This is most important thing in the limit. Intermediate form. How? What is the limit? And second thing, limit of what? We always find limit for a function. Then next, where and why. Where and why we find a limit at a point. Where we find a limit at a point. Why we find a limit? This implies that a value of x generally where a which takes indeterminate form. Then indeterminate. What is indeterminate form? This is most important thing. Indeterminate form. Seven types of indeterminate form are given in the limit, which has helped us to solve every kind of problem. First kind is 0 by 0 form. This is called as indeterminate form. Infinitive by infinitive, infinitive minus infinitive, 0 into infinitive, 1 to the power infinitive, 0 to the power 0, infinitive to the power 0. These 7, first, second, third, fourth, fifth, sixth, seventh. This 7th type of form is called indeterminate form in limit. This is not exact 1, this is not exact 0, this is not exact 1, not exact 0. This tends to 1, this tends to 0, not exact 1. Is less than 0, less than positive 0, less than 1 and also positive 1. This idea comes to the neighborhood. Suppose this is the region, this is a 0, this is the smallest, goes from the right side and goes to the left side. This is 0 plus, this is 0 minus. So at x equal to 0 plus, what is the 0 plus? This 0 plus is a real number which is greater than 0. The difference between 0 and 0 plus is very less. And what at x equal to 0 minus at x equal to 0 minus, this is also same. 0 minus is a real number which is less than 0. 0 minus is a real number which is less than 0, difference between 0 minus and 0 is very less. At x equal to 0 minus, this is 0 minus, this take from 0 to left hand side, this is goes to right hand side as 0 plus. For this case, this is called the right hand limit, this is called left hand limit at x equal to 0 minus. By the concept of neighborhood, we find a limit at x equal to a point A. By the concept of neighborhood, this is the neighborhood concept. By the concept of neighborhood, we find a limit at x equal to A. This implies that we have find a limit x tends to A plus and x tends to A minus. This is the x tends to A. This is not exact A. It means that is x not equal to A, but value of x is some positive value, some negative. Okay. For understanding the concept of limit, we goes to the some problem. How to find the limit at x equal to A? Suppose you give a function f of x equal to x square minus 4 by x minus 2. By this function, we generally good knowledge about the limit. What is the function? Function is f of x equal to x square minus 4 by x minus 2. As x approaches 2, then if x equal to 2, how you can find that? If x equal to 2, 4 minus 4 by 2 minus 2, this is 0 by 0. This is one of the indeterminate form. Okay, then define the function f of x. What is f of x? X square minus 4 by x minus 2, or not defined. When not defined? If x equal to 2. If x equal to 2, this is an indeterminate form, this is not defined. If x not equals to 2, then this is the there. You can reduce it a square minus b square form. A square minus b square form, this is goes to a plus b, a minus b. For this case, x square minus 2 square, this is x plus 2 x minus 2. So this is goes to x plus 2 into x minus 2 divided by x minus 2. So this is x plus 2. If x not equal to 2, if x equal to 2, then the is the indeterminate form, then function does not exist. If we take it graphically, okay, in the function value x, this goes to f of x. Also, if we take x and this is goes to f of x. When we take value the x value 1.9, then we can see that 1.9 plus 2, since what is the function for that case, f of x equal to x plus 2 if x not equal to 2, not defined if x equal to 2. So if x equal to 1.9, this goes to 3.9. If 1.99, this goes to 3.99. Continuously you proceeding this case at the 2, at the goes to 2, then this is goes to 4. Similarly, if you goes to the right hand side, this is 2, this is 2. For left hand side, small neighborhood 1.99999. This is right hand side, small neighborhood 2.111. So if you take 2.1, then what is the value? 2.1 plus 2, this is 4.1. 2.01, this goes to 4.01. 2.001, this goes to 4.001. If you continue this process at 2 from right hand side, 2.001, this from the left hand side, this is from LHS left hand side, LHS it goes to 4. So by putting value we see that this is from the left hand side, so left hand limit extends to 2 minus, this is not exact 2, but difference between 2 and 2 minus is very less. It f of x equal to 4, and also limit extends to 2 plus f of x equal to 4. At this moment, however we read, we cannot say that this limit is 4, because at first we read existence of limit, then we can find that limit extends to 2 of f of x equal to 4. If we read existence of limit, then we can say that, but at this moment, however we read, we say that this is the left hand limit, this is the right hand limit, because these are neighborhood. From left hand side, this is right hand side, so these two value are we are okay. Then graphic, same we calculate this the numerical type. Same thing we can say about the same problem. At this way we did a graphically also, but at the left hand limit at x equals a, this is left hand limit from the neighborhood, but what you can say the definition, as x approaches a from left side, from left side this means that if the point A, this goes to from the left side, okay, then the value to which function approach the call, then the value to which function approaches is called left hand limit. It is denoted as limit extends to a minus f of x. If exists a finite number, this is L1 is the limit. Similarly, you can write a right hand limit at x equals to a. Similarly, as x approaches to a, turned upon right side, this is from the right side, okay, this is from the right side, this goes from the left side, this is left hand limit, this is right hand limit. So as x approaches a from right side, this is a, okay, this is the point from right side, which function approaches is the called right hand limit, RHL. It is denoted as limit extends to a plus f of x equal to L2. Then we say about the existence of limit, right hand limit. Then we say about the existence of limit. Most important thing in limit, existence of limit. If limit extends to a f of x is said to be exist, if limit extends to a minus f of x equal to limit extends to a plus f of x, a finite quantity. This implies that limit extends to a f of x exists if right hand limit and left hand limit exist, and this is finite quantity. This is finite. This is most important one. Finite. Both are equal. Then we say that at this point limit exists. After that we say that one-sided limit. What is one-sided limit? One-sided limit means this is right hand limit, this is left hand limit. One of them exists, another does not exist, then this is called one-sided limit. For first case, if function is not defined in left neighborhood of x equal to, if function is not defined in left neighborhood of x equal to a, but if limit extends to a plus f of x equal to a finite quantity, then we say that limit extends to a f of x equal to limit extends to a plus f of x equal to a finite quantity. Similarly, we can say that if a function is not defined at right hand limit, but if function is defined in left hand limit, limit extends to a minus f of x equal to a finite quantity, then we say that limit extends to a f of x equal to limit extends to a minus f of x equal to a finite quantity. But this case limit extends to a plus f of x not defined. For this case left hand limit not defined, limit extends to a minus f of x, this is not defined. Then these two conditions, we say that this is one-sided limit. Either right hand limit exists, left hand limit does not exist, or right hand limit does not exist, left hand limit exists. Some important concept to calculate limit. Some important concept. 1 by very small quantity, very small positive quantity, this goes to infinity. Very small positive quantity, this goes to infinity. Or 1 by 0 plus, this goes to infinity. 1 by very small negative quantity, this goes to minus infinity. Or 1 by 0 minus, this goes to minus infinity. Okay. Also 1 by tending to infinity or minus infinity, this goes to 0. A number, this is also important, a number between 0 and 1, a number between 0 and 1, a number between 0 and 1 to the power infinity, this also goes to 0. Let us discuss some example on this topic which are discussed about this video lecture. Example, problem, whatever it is said. One side limit example. Limit x tends to 2 positive mod of x minus 2 x minus 2. What is the definition of mod x? Mod x, this is x when x greater than 0, minus x when x less than 0, 0 when x value takes 0. This is the definition of mod x. This is basic criteria. At first, starting the video lecture, we also say that some special kind of function we use or limit, the mod function. This is the mod function. For this case, we use simple look like the basic definition of limit. Limit h tends to 0 for x. This is x tends to 2 plus, hence 2 plus h minus of 2 by 2 plus h minus 2. This is a mod. Put there x equal to 2 plus h. Only plus for this is a right hand limit. Okay. If this is left hand limit, this is 2 minus h. So here, for this case, 2 for this limit h tends to 0 mod of h by h, this equals to 1. Since h tends to 0, this not exact h equal to 0. If this exact h equal to 0, this is positive. So at least some neighborhood, positive neighborhood. If this is 0, this goes to the indeterminate form. Then we have some other rules. But this is not exact 0. This is greater than of 0. Then this value is 1. For similar problem, if we take left hand limit, since this is one side limit 1, if similar problem, if we take left hand limit x tends to 2 minus x minus 2 x minus 2. In this case, we see that limit of h tends to 0 mod of 2 minus h minus 2 by 2 minus h minus 2. This 2 cut, this 2 cut. So for this case, limit of h tends to 0 mod of minus h divided of minus h. For this by definition of mod function, we can consider that this is that. So this value goes to minus of 1. Hence, what we do that? Limit x tends to 2 minus f of x, the function value is minus 1. Also we get that limit x tends to 2 plus f of x, function value is 1. However, see that this is left hand limit 2 minus, this is right hand limit positive for value 1. For this case, by the existence of limit, we can say that by the existence of limit we say limit x tends to 2 f of x does not exist. Why limit does not exist? Whatever say the existence of limit says that limit exists at the point 2 at x tends to 2 if limit x tends to 2 minus equal to limit x tends to 2 plus equal to a finite quantity. a finite quantity, then we can say that limit exists. Then we can say that limit exists. But there we can say that left hand limit is -1, right hand limit is +1. So both are not equal. Limit exists, but both are not equal. For this case, right hand limit exists, left hand limit exists, but limit does not exist. Both the value are different. So that case, by existence of limit, limit extends to 2, f of x does not exist. Same problem we can see that by the graphical idea, sum of graphical idea. This is the example, this is y. So okay. Okay, then this is the 1, this is 2, this is 1, this is 2, this is 0, this is origin, this is 1, this is 2, this is 1, this is 2. Okay. For this case, if we plot the graph, what is function f of x, function f of x equal to mod of x minus 2 by x minus 2. Right hand limit, what is the right hand limit? Right hand limit 1, left hand limit is -1, but at the point 2, at tends to limit does not exist. So when we take the left hand limit, this goes to 1, this goes to 2. We consider that for this case, at the point of 2, function does not exist. At the point of 2, function does not exist. If x equal to 2 minus, sorry, this only when the function does not exist at the point. If x equal to 2 positive, at the positive neighborhood, okay, this function at the point 2 does not exist, but the function value is goes like the 1. If x tends to 2 minus, then function value is goes to -1. This is the -1, this goes to -1. So but at the point 2, function does not exist. By the graphical idea, we can say that from this picture, if this picture is given, otherwise not anything, what is the value of limit x tends to, if this only this picture is given, okay, then however we can say that value of limit x tends to 2 plus f of x, function whatever I don't know, but this graph, this plot is given, x tends to 2 plus, x tends to 2 plus positive neighborhood, this function value is goes to 1. Limit x tends to 2 minus f of x, 2 minus function value goes like to -1. So this is that. By the graphical idea, we can find the always limit value. Then some properties of limit, the basic property, some of the property. Okay. If limit x tends to c, f of x equal to L, and also limit x tends to c, g of x equal to m, where L, M, N should be finite, then property number 1, limit x tends to c, f of x plus g of x, what is the value? Limit function value of f or g is sum. Second property, if limit x tends to c, product of two function f of x of g of x, it also, what is the subtraction? Limit x tends to c, f of x minus g of x equal to L minus m. Fourth property, limit x tends to c, f of x by g of x equal to L by m. it must be provided that m should be not equal to 0, because it's m equal to 0, then it does not meaningful. Both of for property, we should remember that at first limit exists and finite quantity. Then we should talk about this type of four property. This four property many times used in so many problems solved. What is the next? Various strategy to evaluate of limit. Various strategy to find limit, to find evaluate limit. So many types. We discuss 2 or 3 types. First one, factorization. Second one, rationalization. Third one, using substitution. This fourth one, this method is one of the most special name, using law of love. And also fifth, binomial. Here we discuss factorization, rationalization, use substitution, using law of love, and this rest of them. For factorization, we need so many algebraic formula, but we write one or two. A cube minus b cube, this is a minus b square plus ab plus b square. A cube plus b cube, a plus b square minus ab plus b square. A square minus b square equals a plus b into a minus b. These three mainly used in the factorization problem. So let us do a problem, factorization problem. Limit x tends to minus 3 x to the power 4 minus 6 x square minus 27 by x cube plus 3 x square plus x plus 3. This also we solve that factorization problem. Okay. Also this problem, limit x tends to minus 3 x to the power 4 minus 9x square plus 3x square minus 27 by x square into x plus 3 plus 1 into x plus 3. This problem you can solve. So I think this is most difficult, so we can solve this. Second problem, limit x tends to minus 3. When the limiting problem is given, at first we put direct value of minus 3. If this is take the indeterminate form, then we use this 5 types. So if you put minus 3, then this is 0 by 0 form, so indeterminate form. Then we goes to the factorization type. Then we take the factorization type. Okay. So however, this is we try to reduce this factor term, x to the power 4 minus 9x square plus 3x square minus 27. This factor goes to x square minus 9 into x square plus 3. Nothing to do, only we try to distribute the factor, and for this case denominator part x square into x plus 3 plus 1 into x plus 3 this, if we common this x plus 3, then other rest of term x square plus 1. Okay, x square plus 1. For this case, we also reduce that x square minus 9. If we divide it a square minus b square formula, then x minus 3, x plus 3, and also x square plus 3. So by that case, we write that limit x tends to 3 minus x minus 3, x plus 3, x square plus 3 by x plus 3 and x square plus 1. For that case, we can say that this goes to, sorry, just typing mistake. This goes to minus 3, this goes to minus 3. Okay, now if we put that, we can see that this term goes to 0, this term goes to 0, so all rest of them goes to, this is 0 by 0, this is indeterminate. Okay, but for that case, that x plus 3, x plus 3, this is cut. So this part is does not, now is does not hold 0 by 0 form. Then we put the value limit x tends to minus 3. This x tends to minus 3, not exact minus 3. If exact minus 3, then we don't cut this. Okay, just remember x minus 3, x square plus 3 by x square plus 1. So what is the value? Then we put the value, because it does not form 0 by 0. We at first we say that when it does not take from 0 by 0 form, we put the value directly at the point. So this minus 3, minus 3, minus 3 square 3 plus 3 by 9 plus 1, minus 3 square. Okay, so this is minus 6 into 3, 9, 3 square, this is 9, 9 plus 3, 12, this goes to 10. So this divided is 2, 2, 6, 12, 2, 5, 10. So this is minus 36 by 5. This is final answer. For solving limiting problem, you should remember this. If it does not form any types of intermittent form, then directly you put the value, whatever value you gave, this is the final answer of the limit. Okay, then next, substitution. This is a substitution. If any quantity, for substitution you should first notice that if any quantity repeatedly same thing, then put this function as some numerical or alphabet t, x, any of this. For this case, we solve any of the problem. Remember, when any quantity repeats it same thing, repeated same thing, then we solve the problem. We see that here limit x tends to pi by 4, 1 minus cot cube of x by 2 minus cot x minus cot cube x. We see that, for remember portion, any quantity repeated same thing. To cot x repeated here 3 times, let we take cot of x equals t. If we take cot x equal t, similarly the limiting value should be changed. X tends to pi by 4, the given limit, when x tends to pi by 4, Then we put cot pi by 4 equals t. This implies that t goes to 1. So limiting value should be changed when we change a dimensional. So limit t tends to 1, 1 minus t cube by 2 minus t cube. Then what we do next? At first we put t equal 1. If t equal to 1, this is 0 by 0 form. Then we substitute this factorization problem or rationalization problem or law of loss, any of which criteria meets, then this problem solve this criteria. So here we try to factorization. So, limit t tends to 1, limit t tends to 1, 1 minus t, this is a cube minus b cube formula, whatever we write first, 1 minus t, 1 plus t square divided by, if we minus common, t cube plus t minus over 2, this term, then 1 minus t, 1 plus t square divided by minus 1 minus t minus 1. If t minus 1, t square plus t plus 2. Okay. So whatever you find, if we limit t tends to 1, if we carefully notice that if we common this term minus, then we cut this. Limit t tends to 1, 1 minus t, 1 plus t square, t minus t plus 1, t square plus t plus over 2. So these two terms cut, because t goes to 1, t tends to 1, t is not exact 1, so this term cut. For this term, we notice that for this term, this makes 0 by 0 form. But whenever we cancellation that, it does not take from 0 by 0 form. T tends to 1, 1 plus t square, t square plus t plus 2. So from there we can see that this is not 0 by 0 form. So we put the value 1 plus 1 plus 1, 1 plus 1 plus 2. But this value goes to 3 by 4. This is the final answer. For these two problems, these 2 or 3 problems, whatever we imagine that. At first, if you calculate the limit, first you notice that this is indeterminate form or not. If this is not indeterminate form, then we directly put the value. If it's indeterminate form, then we calculate some of the special case. At last, we say that rationalization. Whatever we took the problem, then we solve this rationalization. Limit x tends to a 1 square root under root of 5 minus 2 by root of 2 minus x by 2 minus 1. This is the given problem. What is the first criteria? Put value 1. If we put value 1, this is goes to 0 by 0 form. Then this is indeterminate form. So we took something. This is rationalization form. Rationalization form, limit x tends to 1 at first, the denominator part. So root over 5x minus 2 into 2 minus x, the rationalization is root of x plus 1 divided by 2 minus x minus 1 into, for this rationalization part, square root of 5 minus x plus 2 into 5 minus x plus 2. Okay, this for this term and this term, if we see that this is the a minus b or a plus b, so this is a square minus b square. Limit x tends to a, this goes to 5 minus a square minus b square, 2 square, so this is 4 into square root of 2 minus x plus over 1, 2 minus x minus 1 square root of 5 minus x plus 2. So here you can see that if we compromise that, calculate that limit x tends to 1, then this is minus x plus 1, this also root under 2 minus x plus 1, this also minus x plus 1, and square root of 5 minus x plus of 2. These two terms cut because x repeated same things. X not equal to 1, x tends to 1, so cut this. So what is the value? Value is limit x tends to 1, root of 2 minus x plus 1, root of 5 minus x plus 2. We take at the putting the value 1. This is not 0 by 0 form because this is 1, 1 plus 1, 2, or this is 5 minus 1, 2, 5 minus 1, 4, square root of 4 is 2, is 2. So this is not 1 plus 1 by 2 plus 2, this is 2 by 4, this goes to 1 by 2. This is the final answer. Last property of this lecture, law of love. What is the law of love? Law of love, we use this types, the special kind of limit finding. When we love to create infinitive in denominator, and 0 in numerator. This name not in the book, this is come there. We love to create infinitive in denominator and 0 in numerator. So for this type of problem we mainly use 1 by infinity goes to 0 and tending to 0 by non-zero term, this goes to 0. These two mainly use main things in law of love. We also create denominator 2 goes to infinity and numerator goes to 0. Also use both of these properties to solve this problem. For example, limit x tends to infinity, x cube plus x square plus 5 by 3x cube plus 7x plus 8. Here we notice that highest power is 3 x cube. If we divide both x cube, then this goes to denominator part and x tends to infinity, then y goes to 0. So limit x tends to infinity, if we divide x cube, both side x cube, so 1 by x plus 5 by x cube by 3 plus 7 by x plus 8 by x cube. For this case, by limit property, we divide the limit x tends to infinity by this, limit x tends to infinity by this 1 plus 1 by x plus 5 by x, 3 plus 7 by x plus 8 by x cube. Also you can break out this from additive property, limit x tends to infinity 1 for this case. For that case you can go that 1 by infinity, this goes to 0, 5 by infinity, this goes to limit x tends to infinity 1 plus, you can write that, or see this goes to 1, this is when extension infinitive, this goes to 0, this term goes to 0, this also 0, this also 0. So what is the value? Value is 1 by 3. This is about the law of symmetry. Here we end the lecture. All of them limit problem solved by the help of this property.